In this video we will go over extrusion and edge objects in Road Architect. Adding any kind of object to the road will involve the extrusion and edge object system. A road is made up of nodes or spline nodes. Each spline node has an extrusion and edge object system attached to it. Extrusion objects refer to objects such as railing, center dividers, and other connected objects. Edge objects refer to objects such as road signs, street lights, and other unconnected objects. First, we will go over extrusion objects. In this example, we will create a center divider K-rail or cement barrier. First, select the node which you want to add the K-rail or center divider to. In this case, we are selecting node number 2 on road number 1. Once you have this node selected, in the inspector window, find extrusion and edge objects. We're going to grab one out of the wizard. Click Open Wizard, and it should open this window. K-rail is the first option. Each extrusion object, by default, starts at the base node and extends all of the way until it reaches the next node in the road. Nearly all aspects of an extrusion object can be modified. Make sure that you have the node selected in which you created the center barrier at. Find extrusion and edge objects again in the inspector window. You should see a K-rail listing as number 1. Expand this and you'll see all of the options available to you with this extrusion object. The first option is the name. This is helpful when you're saving it in your library. The next options pertain to the prefab. Prefab can consist of a single prefab for the actual extrusion along the spline and start cap and an end cap. In this case, I'll just grab them from the directory and show you what they look like. We made these in 3ds Max and then imported them into Unity. That is the main prefab used on the K-rail extrusion. And this is the cap used on both the end and the start. Using two separate prefabs allows a lot less triangles to be used. The caps are only used on the very start of the extrusion and at the very end of the extrusion. So in this case, the main prefab is extruded along the entire length of the extrusion. The next option is material override. Use this option if you wish to override the materials for this prefab. The next option is extrusion axis. This is the axis in which the mesh is extruded upon across the entire length of the extrusion. Change this option if you're getting an incorrect repeating with your mesh. For instance, if we try and switch this K barrier to an x-axis, you get a lot of errors because it wasn't designed along that axis. Switching it back to the z-axis corrects these issues. The next 4 options pertain to the location of the extrusion. The start parameter refers to where the extrusion starts. Raise or lower this value to alter the start of the extrusion. The next option is end parameter. This allows you to change the ending point of the extrusion. You can raise or lower this value. The next option is trim start. This will trim the start of the extrusion. This is helpful under certain scenarios when you are using these with bridges or tunnels that require precision. Trim end does the same thing except for the ending. It is also used for unique scenarios involving bridges mostly. The next option is match ground. Having this checked will attempt to have the entire extrusion flush with the ground. This is helpful when you're using an extrusion off of the road as a barrier or other similar items. The next 2 options pertain to the repeating mesh. Let's drag that back onto the scene. And the first option is vertex min max. This value is a percentage. In this case, the default is 10%. meaning it will detect the outermost vertices and then count 10% of the distance back towards the middle, and every vertex it encounters in that area, it will count that as a connection area. And then each area will be connected along the entire extrusion. If you're having problems with the mesh not correcting properly, or if you have a extremely detailed repeating mesh and there's a lot of vertices in this area, you can try lowering this percentage or raising it to try and fix your issues. Most of the time you'll never need to change this value. In the creation of every single included item in Road Architect, we've never had to alter this value. The next option is vertex matching. This number is the precision value in which a vertex is considered matched with another vertex, meaning that it has to match 2 out of 3 axis values in order to be considered a match. The top value for this vertex, located at the very top right here, is considered a match with this vertex value at its counterpart at the very top right, because it matches 2 axis out of 3 axis location. What considered a match is it's equal to within 0.005 or 5 millimeters. If you're having issues with vertexes not matching up properly when you're extruding a mesh, you can try altering this value. And once again, we have never had to alter this value with any of the included Road Architect items, but this option is here in case you run into any problems. The next option is UV repeat axis. This allows you to change the axis in which the UV repeats. If you have none selected, it will default to what the FBX import says. You can change the axis by selecting from a drop-down. In this case, we just switched the x-axis. Now let's switch to y-axis, and everything's messed up. This is more of an option used with more advanced bridge options and other more advanced things. If you're using it as a basic extrusion road item matter, you probably won't ever need to use that option. Using the next option, match road definition, allows you to try and force the extrusion to match the road definition. The road definition is the area in between road slots. If you remember in the previous video, you can set this option, the space between each slot in the road. It's essentially the resolution of the road. In this case, our road is 5 meters and our custom mesh is already 5 meters long. But if you had a custom mesh that was only 4 meters long, you could select this option, which would try to stretch the mesh to 5 meters to make it flush well with the 5 meter resolution road. You can also try this with custom meshes that are larger than the road definition, and you might need to alter the UV or the rotation of the mesh during this scenario. And once again, most of the time you'll never need to use the match road definition option. It is just included as a just-in-case thing. Even if the custom mesh does not match the road definition, it will still look close enough to where it won't be an issue most of the time. The next options are vertical options. These are used for a variety of applications, the primary one being bridges. But we can go ahead and show you with this center divider what this can actually accomplish. The magnitude is the magnitude in which the extrusion is raised above the spline. Right now it is set at 0 meters, but we can alter this with the slider. A positive magnitude raises it, a negative magnitude subtracts it. Right now I raised it to 9 meters, so it is currently sitting 9 meters above the spline. Another feature is you can edit the curve of this vertical rise in magnitude. let's change it to one of these presets that we have down here and a simple hill like looking feature. So as you can see, you can generate some pretty unique items, which aren't really useful for a road but are extremely useful for bridges. The next option is horizontal offset. This is the offset from the center. If it is positive, it'll offset to the right. If it is negative, it'll offset to the left. You can select a preset as a helpful way to speed up things. For instance, if we want to make it the barrier on the right side of the shoulder, we would need to select match shoulder right edge 8 meters. And it automatically puts it on the very right of the road for us. This also has a slider option if you want to customize a more exact location for a horizontal offset. And just like the vertical options, this can be adjusted on a curve. In this case, we have selected a preset, and you can make the curve adjust to pretty much any possible position. When you are using a customized curve for this, any of the vertical offsets or the horizontal offsets, the magnitude really does translate to a magnitude of the curve. The next option is the vertical cutoff. This pretty much will only ever be used on suspension bridges and arch bridges. So we'll skip that option for now. The next options pertain to the start and end of the extrusion. Right now, the push endings down option is selected. And what that does is shoves the very start and very end of the extrusion down into the ground. This provides a very realistic look when it comes to most railings. For instance, K-railing, W-beam railing in real life is typically bolted down into the ground in a fashion similar as this. You can override this value by clicking Override Down Value. If you have this option unchecked, it will set the K-rail back to default. And you notice that our end caps and start cap work very well with this. We've already placed 7 sand barrels at the other end. Let's place something different at the end here. We're going to simply put a warning sign here at the end. You can adjust many aspects of the start and end objects, standard transform data, and you can use your own custom objects very easily by selecting the standard object gatherer in the UI. The remaining options pertain to the collision detection of the extrusion itself. The goal is to have the most simple collision as possible. Primitive bounding boxes or spheres would be ideal, but they're not always feasible. In this scenario with this curved K-rail, it is not feasible. There's an automatic collision mapping system within Road Architect. Right now, simple triangle is selected. it will automatically attempt to calculate the most simple and most accurate triangle system to use the collision. In this case, it perfectly calculates the middle and all the edges, and we end up with a pretty realistic mapped collision of the extrusion. The options are simple triangle, simple trapezoid. You can use the collision. You can use the mesh itself as a collision, which would be very expensive due to all the triangles. And the final option is straight line box collider. This is used on straight line bridges, or if you have a very straight road, you can use it for that. Let's select simple trapezoid. As you can see, it's changed it to a trapezoid based on the bounding dimensions of the K-railing, but it sticks out a little bit too much. So if we wanted to use this trapezoid collision, we would want to make this represent the K-rail a little bit more accurately. First, we want to find automatic, simple, and uncheck, because we need to manually edit. On the bottom left and bottom right, which is the very bottom of the K-railing, it looks to be pretty accurate already, so we will leave those values alone. Find the top values, and the first thing we know is that they are too far apart. The top of the railing is at least half of the bottom. So let's cut these values in half, and maybe a little bit more. Now we've got a little bit more accurate map, collision map, of the K-railing. Let's switch it back to triangle, automatic. The other two options are you can change it to a convex collider, which most of the time doesn't make sense, especially on curved extrusions, and you can also change it to a trigger. Final options are rotation options. You can flip the Y rotation, and this is helpful with certain one-sided railing. Let's go ahead and add another railing that is one-sided onto this road. We're going to add a wooden W-beam railing on the right side. Let's move it over a little bit, and it's facing the right way. Let's say that we want to move it to the left side, make it a -8 meters, and now it's facing the wrong way. Scroll down to the rotation options and select Flip Y Rotation. This will automatically flip the entire extrusion properly for you to allow for use of one-sided extrusion objects. That about covers a good overview of all of the extrusion options. If you need more information, either email us or look at the online manual. The online manual details every single option in Road Architect. Next, let's go over edge objects. So let's delete these two extrusion items that we have created. Next, let's add some edge objects, traffic cones, to the road. Select edge objects from the category, and you're presented with all of the edge objects. Actually, let's add some street lights. We'll add some street lights to the right side of the road. So select street light single-sided. By default, it'll put them in the center of the road. So just like the extrusion items, it's a similar layout when it comes to vertical, horizontal, and rotation options. I'm going to go ahead and move them to the shoulder right edge. From the start, the first option is the name. This is used when you're saving and loading from a library. The next option is selecting the actual object itself. It can either be an FBX or a prefab. The next option is the material override. This will allow you to override the material used on the FBX or prefab. The next option is combined meshes. This will combine every single mesh of the edge objects. Right now we have about 6 streetlights. If we check this, it will combine every single streetlight into one mesh. This isn't useful for this particular implementation, but it is useful for others. Single object only informs the system that you only want one object of this to exist with this. This is helpful with road signs and other unique things that only appear once on a section of road, like a speed limit sign would be a good example. If you select this option, it will remove other irrelevant options and provide you with a slider to move the location of the single object. The next option is static, which will mark these objects as static or unstatic. The next option is match ground height. This will attempt to place each object flush with the ground or whatever is below it. The next option is distance between objects. For these streetlights, the default is 30 meters. If you change this option lower, it will create more streetlights closer to each other. As you increase the option, it will increase the distance between them. The next option is match road definition. This will attempt to match the road definition, the starts of the road definition. This option is only useful for very complicated bridges. Most of the time you will not need to use this option. The next option is start parameter and end parameter. These are exactly like the extrusion options, where it determines the start and the end of the repetition of the edge objects. The next options are vertical and horizontal offset options. These function exactly the same as the extrusion option, vertical and horizontal options do. You can raise them, you can make them curve, and you can offset them horizontally. And you can also offset them horizontally with a curve. And the final options are rotation options. These rotate the mesh itself in each location of the mesh. So now that we've gone over the options, let's go over a few more examples. Let's delete these streetlights and let's add some traffic cones now. Open up the wizard and then select Edge Objects as the category. And let's add some rigid traffic cones. We don't want them down the center of the road. We're going to be making a construction zone. So let's make it curved. And select one of the preset curves. That one looks good. Then change the preset. That one looks good. Now we have a somewhat realistic traffic cone scenario if there was construction on this side of the road. Next, let's go over a speed limit sign. Let's delete the traffic cones and open the wizard and then select Edge Objects again from the category, and let's select one of the sign options. These signs are split up into different dimension categories. All 300 or 330 plus signs included with Road Architect are based on the actual federal guidelines and state guidelines to the size and ratios of the signs. Let's select 396. You'll notice that it provides you with a material search term. This allows you to copy and paste this material search term, and then you click the materials and paste the search term, and it will automatically populate the list with all of the materials that match this sign's dimension. In this case, let's select the 50 mile an hour speed limit. Looks like it placed it right on the node. Let's move it to the right side of the road. Actually, let's make it on the left side of the road so we can get some sunlight on it. Right now it's facing the wrong way, so we need to rotate it 180 degrees. This is how you place a road sign. You can use the repeating feature for if you have a turn coming up and you need turn signs. Simply unselect the single object only and it will repeat it, just like the streetlights. Now that we've looked at extrusion and edge objects, let's look at the last category in the wizard. Select a node and then click Open Wizard. From the category, select Other Groups. Here are some pre-made groupings of extrusion and edge objects to get you started. In this case, let's select Left Turn W-beams. Notice that this provides the W-beam and the left turn signs for this upcoming left turn. There are a few other options, and many options will be added over time. Let's add a different other group to this node up along further the road. Let's add fancy railing on either side of the road with street lights. Next, we will go over two very advanced features of extrusion items. You can skip this if you are not concerned about advanced bridge construction. First, let's create a very large suspension bridge, and then we'll go over the arch bridge after this. If you're confused by the steps I'm taking to create the bridge, you can view the bridge tutorial video and then come back to this section in the video. I'm opening up the wizard for the bridge start node and selecting large suspension bridge. And the suspension cables use the vertical cutoff previously mentioned in the extrusion objects. Find suspension cable, we'll look at the right one, and then scroll down to vertical cutoff. If you have this enabled, it opens up many more options. If you view the online manual, it gives you a very specific look and settings of the suspension bridge cable setup and the arch bridge setup. The match spline height attempts to match the spline's height. If the cut direction toggle is enabled, the match spline height is applied to the base. If the cut direction toggle is disabled, the match spline height is applied to the top, which is the case for the suspension cable. So what's happening here is the vertical cabling lines are getting cut off as it hits this vertical magnitude curve up here. So this provides a smooth look across the entire suspension bridge cabling. You can also edit the height cut offset. Sometimes if you are using some more complicated meshes, you'll notice some poke through of the cutoff, and you can slightly adjust the cutoff to raise or lower depending on your needs. Similar to the bottom, you may notice some offset issues if you use more complicated meshes, and that is what these offset options are for. The height cut offset, the offsets offsets the base cut level. So down here, for example, this setting will affect a suspension bridge cable's bottom area and will affect an arch bridge's top area. The mesh cut offset is the top part that we were looking at before. The vertical height cut offset, which is applied to the cut ends of the mesh. This allows fine-tuning of the cuts. And this is for when the vertical cabling sometimes cut through the tops and you can tamp it down or raise it if it doesn't reach far enough. Next, let's look at an arch bridge. Let's create another road. Let's create the bridge, and then select a deck arch bridge. In this case, I'm going to use 12-meter separated beams since it's a very small arch bridge. So like the suspension bridges, these vertical cutoff options are very similar except reversed. So open up the arch base and go to the vertical cutoff, and you'll notice that they mirror the suspension bridge except in opposite to create a very nice looking arch. Once again, the respective cut offset options will help you mitigate any poking through issues on top or bottom. One of the more common issues with suspension bridges, this will also be covered in the bridge video, is sometimes the tops don't match exactly. So let's reselect the suspension bridge, and where that happens is the vertical curve. You simply need to just slightly alter the cabling to fit in the top more exact. This is due to the dynamic nature of these bridges and the direction and height of the bridges. That about covers the overview of the extrusion and edge objects. If you have any questions, email us or look at the manual. If you are looking to create a custom bridge or custom railing or anything custom related, you can view our tutorial videos on creating meshes in 3ds Max and then importing them into Unity and using them in our road systems. If you are looking at creating a custom bridge, I would recommend creating several bridges with our included bridges in the wizard, and then examining each option and looking at how they were created. Most of the setups are extremely simple. Even the suspension bridge is pretty simple. The base, the railing, the secondary railing, and some of these suspension bridge cable holders are all created via the standard rail and edge object system. And they are pretty straightforward and just a matter of aligning these up properly to look like they fit on the bridge. The suspension bridge pillars are simply two large meshes using the edge object system as a single object placement. Here and here. The only two real complicated features of a suspension bridge are the cabling, which we've just gone over. Most of the other bridges are very simple and don't include the vertical cutoff issues with a suspension bridge or arch bridge. Let's look at a more simple bridge. Let's create a simple causeway. You'll notice there's no arches or bridge cabling, so what we have here is a bridge base, or two bridge bases, extruded along the spline, very similar to railing or anything else. Then we have a repeating edge objects, which are the bridge pillars, a certain meter distance apart with certain start parameters and end parameters. If you would like a road to pass underneath, you might want to align them so they look like they fit in real life. And it's a very simple construction if you think about it. So if you were to customize this, you would want to look at the actual pieces of this bridge. You'd want to find the prefabs and look at them and open them up in your 3D modeling program and edit them and then re-import them and use them here. Customizing these bridges is also very easy. Let's say that we want to change the right railing. Let's change it to one of the included railings, number 7. Very simple to change the railing or any other aspect of the bridge. The final aspect of extrusion and edge objects that we'll cover is the library system. The library system and the wizard system is the same thing. If you save a customized bridge or your own bridge that you built or railing group or any other kind of item, it will be included in the wizard. Let's pretend that we changed this bridge and let's save it as a different group. You can even select a thumbnail for your customized thing and provide description. We'll just leave it as a default. And it is bridge related, so we'll know to put it in the proper category. So let's click Open Wizard, and you'll notice any customized things get moved to the front, and there is our new bridge. So if we were to use again, we simply click it and it replaces everything. You can also save individual aspects of the bridge. Let's go back to some of the things we made at the very start. Let's look at this railing. Let's say we want to save this particular configuration of the W-beam for future use. So expand this, and let's change the name to W-beam custom right side left turn. Click the save button and another menu will pop up. Similar, you can select the icon, a description, and a display name. It is not bridge related, and then hit save extrusion. Now let's click Open Wizard, and under the category extrusion items, our custom is now selected. To delete any of these from your library, navigate to your Road Architect folder, library folder, and locate it in the editor folder, and just delete them from your hard drive.